Hello everyone, and welcome to this theory recording on Y-delta transformations. So first we're going to look at the different configurations of Y or delta connections. So first we start with the Y or T connected elements. So the Y connected elements, as you can see in this diagram, we have the actual Y connection and the T connected element. Similar to the Y connected elements, you can see there's a T connection there. So both of these configurations can be seen as a Y connected elements. And with your delta or pi connected elements, you can see there's a delta connection there, or there's a pi connection in this diagram. And these are interchangeable because we can see that this is one node that's connected there. Now, when we consider Y-delta connections, we want to move either from a Y-connected circuit, which is the circuit there, to a delta-connected circuit, which is the outside circuit, or we move in the opposite direction. So first, let's look at the movement from your Y-connected circuit to the delta-connected circuit. So with the delta-connected circuit, we're going to have RA, RB and RC as the unknowns that we're going to calculate from known values of R1, R2 and R3. So the equation goes as follows. For RA, we're going to have the multiplication of R1, R2 plus R2, R3 plus R3, R1 divided by the resistor R1. If we analyze that, we'll see that for RA, RB and RC, the numerators are the same. However, the denominators are different. So RA, we can see, is actually the resistor at this point and it's opposite to R1. Likewise, RB is opposite to R2 and RC is opposite to R3. So to ensure that you remember these equations, you know that the numerator is the same. It's the multiplication of the resistors R1, R2 plus R2, R3 plus R3, R1 for all of the different resistors, and the denominator is just the opposite resistor. If we now consider the delta to Y conversion, we see in the equation that R1 is RB/RC over RA plus RB plus RC. Further to this, we see that the numerator differs for R2 and R3, but the denominator remains the same. So we can then pick up from that is that we can always determine the equation by saying R1 sits at this point, RB and RC are adjacent to R1. So we will always say it's the adjacent resistances over the sum of all resistances. So by that logic, we can say R2 will be the adjacent resistances to R2, which is RA, RB over the sum of all the resistors. And R3 will be the adjacent resistances. So R3 would be RB, RA over the sum RA plus RB plus RC. Further to this, it's important to note what balanced circuits are. So a balanced circuit is a circuit that will have elements that are equal in magnitude. So you may have circuits where they'll tell you RA equal RB equal RC, or R1 equal R2, which is equals to R3. So this would be a balanced circuit. And in the event of a balanced circuit, the equations in the previous slides will simplify to these two equations. Now, in terms of procedure, remember that the Y-delta transformations are there to convert between Y and delta, but this is typically a last resort once you've identified that you don't have any series or parallel connected circuits. So when you have a question that you need to attempt, the first thing to do is to identify if you have series or parallel connected circuits. And if you do, you then calculate the equivalent resistance based on the series or parallel connections. If you can not identify any series of parallel connected circuits, then you can move on to identify first the balanced Y or delta circuits. So take a look at the delta circuit and the Y circuit and see if you can identify a delta or Y connected circuit. This is important because you may have more than one connection, delta or Y, and one might not be balanced, meaning it might be unbalanced, different values, and the other one may be balanced. So if you follow the approach of determining the balanced one first, it will simplify your calculations and reduce the amount of work that you need to do. Finally, if you don't have any balanced Y or delta circuits, you then need to identify the unbalanced Y or delta circuits and then calculate the value of the resistances and simplify the circuit and then return back to step 1. Thank you for watching this video and enjoy the course.